Alright, B's and G's, welcome to a special frozen edition of Drive-Thru Confessionals. I'm your drive-thru employee, Mr. Ulan, today. Hopefully you have checked Blackboard and maybe you've seen either in the announcements or the assignment section that I've posted this little document here. This is where we're going between now, which is Friday, February 20th, and next Thursday, which is your test day for Chapter 9. Okay, this is totally doable. You guys just have to work and stay ahead, and we're going to utilize our class time next week for you to get help and ask questions. There will not be a lot of lecturing going on in class. That's kind of the point of this video. Luckily for us, all of the sections that we have remaining in Chapter 9 are indeed review in one way or another. So I'm going to cover them all right here, and then we will focus on getting our work done. So, this is a special Stay Cool edition of DTC. What we're going to learn about is three-dimensional Pythagorean theorem. That's maybe intimidating. It is in no way difficult. You guys are going to be great at it. Then we'll do our little intro to trig, which you guys have gotten many times over now, both from your algebra teacher and from me. And then we'll do the little bit tougher stuff, which is applying trig. All right, so the general idea of these is to find diagonals or right triangles that exist in three-dimensional shapes. So what if we were given, let's say, a triangular pyramid? I'm sorry, let's call it a square pyramid. So a square pyramid whose base was a square, obviously. And let's say the slant height of this pyramid was 7 feet, and the base was a 4-foot square. What would be the height of this pyramid? Well, this would actually not be a problem that would involve two right triangles. It would just be a singular right triangle. We're trying to find the height. So you might be best to just pull this out. You got 7, you got 4, you got h. H squared is 7 squared minus 4 squared. 49 minus 16 is 33. And radical 33 is simplified. What if we were asked, let's say the diagonal of a cube is 30 meters. The diagonal of a cube is 30 meters. Find the volume of the cube. Okay, a little tougher now. So we start with the Widmapoi. The only thing we have given is that this thing right there is 30 meters. Well, let's call that x. That makes this x and that x, because it's a cube. Well, I know that the base of the cube is a square. And so from my 30, 60, 90 triangles and 45, 45, 90 triangles, I know that this triangle right here, I'll pull it out. That's a special right triangle. And it's 45, 45, 90, so this pink diagonal is x radical 2. So I know that this is x radical 2. That's an example of how I had to do another problem in order to solve for what I was missing. So now I can say that x squared plus x radical 2 squared equals 30 squared. X squared plus, that's 2x. So 3x squared is 900. So x squared is 300. So x is the square root of 100 times 3, which is 10 radical 3. We wanted to know the volume, so the volume is 10 radical 3 times 10 radical 3 times 10 radical 3. 10 radical 3 cubed, that's where the term cubed comes from. So what you really get there is 1,000 times 3 times radical 3. Hopefully you could kind of figure out how we got that. Radical 3 times radical 3 is 3. We're left with a radical 3. We did 10 times 10 times 10 to get 1,000. So the answer would be 3,000 radical 3 cubic feet. All right. So that's an example of a tough 9-8 problem. All right, so 9-9, we're going back to SOHCAHTOA here. SOHCAHTOA, what's it mean? The sine of an angle is the ratio between the opposite side and the hypotenuse side. The cosine of an angle is the ratio, it's a fraction, made between the adjacent side and the hypotenuse side. And then the tangent of an angle is equal to the ratio between the opposite side and the adjacent side. Okay? So let's say we wanted to find the angles in a 3, 4, 5 triangle. All right? Let's call the first angle that we want to find, let's call it A. Oh, crazy. And according to the A, let's say we'll use opposite and hypotenuse. Opposite and hypotenuse is sine, so I'll say sine. What goes in the parentheses? Well, it's always the angle. We don't know our angle here, so that's why we have a variable in there. Sine of A is equal to 4 over 5. And then, just like every other function in math, the inverse of multiplication was division. The inverse of squaring a number was taking the square root of it. Sine also has an inverse. It's called sine inverse. But if we take the sine inverse of that side, we have to take the sine inverse of that side. So A is equal to the sine inverse of 4/5. So angle A is equal to second sine 4 divided by 5, and you get 53.13 degrees. That's an approximation. And therefore angle B will be 90 minus 53.13, which is 36.87. And that's how you do that. Okay? Alright, moving right along. The only thing new from 9-10 is this angle of elevation and angle of depression. Angle of elevation is pretty intuitive. Most students do just fine with this. So if you are flying a jet, okay, your angle of elevation is always formed with the horizon. So if you see another object approaching you forward, this right here would be the angle of elevation. Right here. Okay? Now, the angle of depression is, students are more likely to get it wrong. So let's say we're in a ship now. A pirate ship. And in our sonar, we spot a pirate submarine. Oh man, submarine. Okay, now, here's where The angle of depression is this. Okay, it's that angle. So what we have to do here is form an upside down right triangle. Where people sometimes get it wrong is they'll make their right triangle like so. This is not the angle of depression, but that is where the mistakes will come. Okay, you can see your book for some good examples of that. Stay tuned to the drive-through confessionals, but watching this video should be enough for you to get going on the remainder of Chapter 9. As you can see, our test is this Thursday, okay? And we have a quiz on Tuesday. We also have a Math Excel assignment due today that I have extended the deadline for until Monday. Special shout out to my boy Nick Bell for getting that done. All right, stay warm, be nice to each other, and we'll see you soon. Miss you guys. Boom!